Assignment 1. Role No. Introduction. Topic: Buffer Overflow Attack. 1. Introduction. A buffer overflow attack is one of the most common and dangerous security vulnerabilities in computer systems. It occurs when a program writes more data into a buffer than it can hold. This extra data can overwrite adjacent memory locations, leading to unexpected behavior, system crashes, or execution of malicious code. 2. What is a buffer? A buffer is a temporary memory location used to store data while it is being transferred or processed by a computer system. It acts as an intermediate storage area between different components, such as the processor, memory, and input-output devices. Buffers help in managing data efficiently by holding it until the system is ready to use it. 3. What is buffer overflow? A buffer overflow happens when a program stores more data in a buffer than its allocated size. Since every buffer has a fixed amount of memory, it can hold only a limited quantity of data. When this limit is exceeded, the extra data flows into nearby memory locations that are not meant to store it. 4. Types of buffer overflow attacks. A. Stack-based attacks. A stack-based buffer overflow occurs in the stack memory, which is used to store function calls, local variables, parameters, and return addresses. When a program writes more data into a stack buffer than it can hold, the extra data overwrites nearby memory locations on the stack. In this type of attack, attackers mainly target the return address of a function. By overwriting this return address with a malicious address, they can control the flow of program execution. When the function finishes, instead of returning to the original location, the program jumps to the attacker's code. This allows attackers to run unauthorized programs and gain control over the system. Stack-based buffer overflow is one of the most common and dangerous types of overflow attacks because it directly affects program execution. Heap-based buffer overflow. A heap-based buffer overflow occurs in the heap memory, which is used for dynamic memory allocation during program execution. The heap stores data that is created using functions such as malloc, calloc, and new. In this attack, when more data is written into a heap buffer than its allocated size, the extra data overwrites adjacent memory blocks. This can corrupt important data structures, pointers, and control information stored in the heap. As a result, attackers may manipulate program behavior, gain unauthorized access, or cause system crashes. Heap-based buffer overflow attacks are often harder to detect than stack-based attacks, making them a serious security concern. 5. Example of buffer overflow: C program. Hashtag include C program. Hashtag include char buffer, gets, buffer, printf, hashtag, return 0. 6. How attackers exploit buffer overflow. Attackers exploit buffer overflow vulnerabilities by deliberately providing very large or specially crafted input data to a program. This excess input exceeds the buffer's storage capacity and overflows into nearby memory locations. As a result, important memory areas such as variables, function pointers, and return addresses may be overwritten. 7. Prevention techniques. Prevent buffer overflow attacks. Programmers should use safe input functions that limit the amount of data entered into a buffer. For example, functions like fgets and scanf, with proper format specifiers, should be used instead of unsafe functions like gets. These safe functions help ensure that input does not exceed the buffer size. 8.